recording. And let me start off with sharing my a few things that I want to talk to you all. Okay. So today is the last class. In fact, this is the first time in my almost 20 years that teaching at Louisiana Tech that we have stretched the class all the way to the very last class. Normally, I probably would end a week before, which a final exam I normally give before the final week. Because as I told you, sometimes we have the senior who graduating is catching up the last class because this is the required class that everyone has to pass. So for the degree candidate, we have to submit that grade by last Monday. Okay, but then I think for the regular grade submission, it's gonna be this coming Monday. So therefore, I'm giving everyone a last chance. Okay, the tech shell, the due date. I think I have extended one time already that the previous whatever extend due dates on May 19th. But then today or by today midnight is the drop dead date. Everything meaning that we're gonna have to meaning we myself and my grader we're gonna start do the grading and then tabulate all your score and everything. So then we can get it done by this weekend, and then Monday I have to submit your grade to the registrar office. So I have looked through all homework and assignment. Majority, everyone has, done a good job. You all have fulfilled the all commitment. Just maybe a few people that I'm giving, those people a large chance, okay, by midnight. So I went back to every single, like all the quizzes and the assignment and reset the deadline to be today midnight. So I think this is your last chance in order to get some of the grade, okay? The main reason I'm doing this, which is I apologize for someone who do a good job, did on time, because I think we discussed among our faculty, during this time, some of you guys may facing some challenge, okay, or some other responsibility. So we try to be as flexible as possible, okay? So again, so by today midnight, if some of you guys have not submitted, including the references, because some of you guys have present your presentation, have done your presentation, but I noticed that you have not submitted the 5 references, okay, which also count toward your grade too. So go ahead and look through, your grade and try to catch whatever the last train, so that you get the grade, okay, or better grade. The grade is not important for me. In fact, the most important for me is you guys learning, okay? So this is the last reminding to you all, especially someone who has not done all the quiz or all the submission of the activities, okay? And then after that, we're gonna continue on a last few presentation. I saw maybe we have 3 or 4 people has not done that presentation. So we're gonna start with, I believe, Jalen. Okay, let me go to the next slide and then let's see. Yeah, Jalen, okay. Go ahead and start your presentation. I'm gonna stop my screen sharing, and then after everyone done presentation, I think today also today class is also your last chance. If any has not present your presentation or done your presentation, please do now, because otherwise I have no time, because I need to finish everyone grading. So I don't want 1 or 2 person to delay the final gradings, okay? All right, so let me stop my screen sharing. And then after the presentation done, then I'm gonna do a final summary from our class, okay? What we have covered so far, and then talk about your presentation bit here and there. And then after that, it's gonna be the last Q&A. All right. So yeah, I stop my screen now. Jalen, okay, go ahead and start, and I will uh, shut off my video and mute once you speak up, and I can hear. I mean, it's coming well.
Can you hear me?
Yes, I can. Okay, so I'm
Okay.
gonna stop my video and mute. Go ahead.
All right. So I did my topic over quantum computers. So I feel it's necessary to explain a little bit about what quantum really means in order to understand exactly a quantum computer would be. There are basic rules that apply to everything on Earth, and we know them as the theory of special relativity written by Einstein, which we all learned about back in physics class. An example of one is E equals mc squared. However, once you get down to the molecular level, the same rules don't apply. The study of those rules is called quantum mechanics. So what a quantum computer would really be is a computer that uses the states of subatomic particles in order to store information, which would greatly increase the computing speed. Quantum computers would be revolutionary because they would be able to do an extremely difficult equation in minutes, while supercomputers we have now might take years to do them. All right, now to the history of quantum computers. So, talk of creating a quantum computer actually began in 1959. Richard Feynman found that as electronic components continued to progress and technology got increasingly smaller, effects from quantum mechanics would begin to occur, which he believed would create a more powerful computer. It wasn't until 1980 when a man named Benioff Paul published a research paper over the quantum computer. His explanation was effective enough that it sufficiently eliminated the issue of excess energy dissipating when trying to create one. Not only that, but he was able to show that reversible quantum computing is possible. Paul essentially laid the groundwork for someone trying to create a quantum computer. In fact, based on Paul's research in 1982, Feynman developed a universal quantum simulator. A universal quantum simulator is a quantum computer that no longer uses a Turing machine, which you can see on the left. Turing machines were proven to slow down computing time, while this new quantum simulator would not. The two of them had made so much progress in the quantum computing field that it attracted the attention of many other scientists to begin working on it as well. The quantum computer fever that many scientists had 20 years ago is still alive today. In 1998, Isaac Chuang, Neil Gershenfeld, and Mark Cubanek created the first quantum computing machine that could output solutions when given data. However, it only worked for a few seconds max and wasn't capable of computing meaningful problems. Their version of quantum computing was also only able to have up to 2 qubits, while the goal was 16 qubits. A quick explanation of qubits: they're normally a subatomic particle like a proton or electron, and they exist in superposition, which means they have the ability to be in between two states. While a bit is normally either a 1 or a 0, and it is predetermined beforehand, a qubit is random and could be either. You don't actually know what it is until you measure it. So they have the potential to be any combination of ones and zeros. In 2000, both a quantum computer with 4 qubits and a quantum computer with 7 qubits were successfully created. The 7-qubit quantum computer was actually created by advancing the method used in 1998 to create the 2-qubit computer. However, neither of the methods used to create these quantum computers would be used on a larger scale. The first method was capped at about 14 or 15 qubits because of the method that they used, if they could even manage to make it that high, while the 4-qubit method couldn't even make it that far. Okay, the current state of art. Quantum computing continued to evolve from 2000 to now, but we still don't have an actual working quantum computer. Google managed to create a 53-qubit chip that demonstrates what they call quantum supremacy, due to the fact that it could complete a task that the ordinary computer could not. It managed to complete a calculation within a few minutes that, according to Google, would have taken the greatest supercomputer we currently have 10,000 years to calculate. IBM made an announcement a few days later that Google's calculations were wrong, and it would really only have taken our current supercomputer a few days to finish the calculation. The two companies are in a mad dash to the quantum finish line at the moment. IBM believes, however, that the goal should not be quantum supremacy, and that the statement itself is very misleading. Quantum computers would only be better at some things and superior in some ways to classical computers, but not supreme overall. Their hope is to one day create a quantum computer that would be worth the economical cost due to those advantages they have over the classical machine. Competing technology. The only machine that a company trying to sell quantum computers would be worried about would be the classic computer. They're already distributed and manufactured. They cost a lot less than a quantum computer would. There are also many tasks that they can do just as efficiently as a quantum computer. I think it would really just depend on how you market it and what target audience you are trying to sell it to. Benefits. The supercomputers we have now would take hundreds of years to compute some of the difficult problems, like how Google explained. Or it could possibly just take a couple days, I guess, depending on what calculations you ask them to do. But a quantum computer is a lot quicker. Those calculations can help model complex molecules in order to create new drugs or even new materials. They can make long-term weather predictions, and they could even reduce the amount of traffic on the streets by dealing with the problem in real time. Some of the drawbacks: quantum computers are very difficult to make due to the fact that scientists have to manipulate the electrons and protons in order to get the qubits necessary to make them. There's also the fact that qubits are often difficult to use. Their ability to be in between states is the reason they're so sought after, but it also makes them very difficult to compute with due to their sudden changes between 1 and 0. It does seem like IBM's new quantum circuits will be able to fix this issue, but it is unknown at this point whether that's true. The wonderful computational power of the quantum computers could be used for illegal hacking. Hopefully people will have protection against quantum computers before that becomes an issue, though. Thank you for listening. Does anyone have any questions?
Anyone has any question for Jones? I do have some, not sure, question or comments. Okay, maybe perhaps question. I think in terms of being productive or in the real world, it's not only how fast you can compute, but also the ease of programmability as well as maintenance, because you don't write program once. I mean, for example, the operating system that you use, Microsoft, I believe that, I think the Microsoft right now, even though Windows 10, but they still reuse the code from whatever the original Windows or even MS-DOS terminal kind of thing. Have you looked into the programmability aspect of quantum computing, and how do they program, I mean, such machine? Because at the low level, the paradigm is completely kind of different. Instead of 0 and 1, you have qubit, which you have many states there.
Right. I don't know if they've ever actually been able to even get into that yet, since they haven't made a quantum computer, so nobody really talked about it. I feel like it would be extremely difficult, and I think that with the quantum computers, they're focusing more on those difficult calculations and trying to form complex molecules and things like that. I don't know if that would be something that they would market the quantum computer for.
And second of all, if someone try to push quantum computing to be mainstream computing, think about, like million of applications out there that, you use every day, or you have written, or even some corporation, just like Louisiana Tech. I mean, the reason why the BOSS system go down every, lunchtime, because of the legacy code. So in that case, I think in order to make quantum computing to be successful, I think it should have ability to convert existing application into quantum computing. That's what I thought, in terms of realistic, I mean, from aspect that I used to work for industry, I would say that that would be a main challenge, making quantum computing to be everyday computing. But I don't want to subside the great potential. In terms of theory, it has significant, much more powerful than what typical computer works. I mean, especially I'm coming from supercomputer aspect, looking into the theory aspect of quantum computing. I think it's gonna give the leapfrog to the next kind of like minds, so that if someone can solve the problem that Julian has mentioned in terms of programmability aspect and maintain and how to control those qubit, the proton kind of thing. Because to turn on and off, I think people already have figured out probably 60, 70 years ago, from switch on off or transistor. And then now you can build circuit and pack million or billion of the circuit into one little kind of chip. I mean, especially right now, like GPU, you guys take a look at the current GPU. Just NVIDIA just make announcement, the code name called Ampere. It has probably, I mean, it's gonna take supercomputing into next step too. And then beside that, last year NVIDIA bought one of the best in class networking company called Merlinox, okay, which I believe that they have eyes to stitch together all these GPU and forming cluster of GPU. So that be another area or competing area to make quantum computing successful, because those technology making GPU, I think, is in production right now. Right now, I believe that quantum computing I think they are still in experimental phase, right?
Right. Yeah.
Okay. Does it make sense to you? I mean, I have not read a whole lot of quantum computing, but I'm dabbing along, reading, I mean, casually.
Yeah.
That's what my take, and people always, using like marketing term, like quantum supremacy and all those kind of things, but in
Mm-hmm.
terms of reality, I think that yet to be seen.
Yeah, it seems like Google is really trying to sell people on it already when they can't even like the machine that they came out with that had 53 qubits was supposed to have 54, but
Mm,
it malfunctioned at the last second, so they only had 53. So like with something stable, they're already trying to get people interested by talking about like
mhm,
quantum supremacy. And
mhm,
so
mhm.
yeah.
Yeah, but regardless, it's very interesting presentation. I think it brings us another perspective that we should not ignore this. We should put on our radar and then see the development, and then try to understand um, what would be opportunities, what would be the challenge that need to be solved. So I mean, for me,
Mhm.
I enjoy some of this technology and start kind of thinking along to see, for example, what would be operating system that you're gonna put on the top of this, and then what would be a software development kit that you would provide to developer, would like the Python or C programming would work the way it should work on, like whatever this digital computing versus quantum computing,
Right. I mean, they were talking about like in theory, you should be able to do a lot of the things the same, but I don't know if that would include programming.
Mhm,
So, and like, it's not like we've ever gotten to use one because we don't
mhm,
have one, so we wouldn't
mhm.
know.
Yeah, I think it's important to have a practical use case, in order to make it useful or practical for the real world. Uh,
Mhm.
but it's a good presentation. Any question before I make the last call for any presentation? Because I know that from I look at the presentation so far, I saw a few people has not present, and then your presentation is 50% out of the whole term presentation. Um, you can unshare the screen, Jalen, and then let me call the last uh, persons that if they still want to do presentation.
Okay, do you want me to resubmit my sources?
Yeah,
Or
please do so. If
okay,
and by the way, if any of you guys have not submit the references or anything, please do now because all those count toward your grade. And the grade, your grade, you get good grade or bad grade, does not impact me. I mean, so I think it's all impact yourself who has not done that. So please do so. All right, let me do the last call. Anyone who has not present would like to present now? Going one, going two, going three. All right, so in that case, I would use maybe perhaps the last few minutes to summarize what we covered so far, or I think the whole quarter, okay? Let me just go back and to share my screen. So let me just walk you through in summary, okay? Um, in my professional experience, I believe that operating system is quite crucial, especially if you guys gonna be a creator of the system in the future. Not only bless you, not only the developer, but also the designer, the um, even I mean, manage data center or whatnot. Because operating system is a critical piece in order to make your hardware works. Like Jillian mentioned about quantum computing. To make quantum computing useful, it has to make it in a way that easy to manage, easy to use like user interface. Okay. So I think we start our class, by giving you introduction of operating system, walking you through the historical aspect, and then talk about each individual environment that operating system can be applied to. For example, we talk about typical notebook, desktop, and then mentioning about your smartphone, smart device, um, refrigerator, IoT, and all whatnot. They all has some commonality because all those require some computing, but also they have a uniqueness in terms of some feature. So for example, when we talk about mobile phone, the critical feature that operating system has to manage better is like power management. Okay. And in that lecture, we also compare and contrast various uh, popular operating systems such as Linux, Windows, Mac, um, Android, or whatnot. Okay, so I think you all start seeing, the layers of all the subsystem that most operating system provides, such as process management, memory management. Okay, then we continue on and talk about OS structure, and in OS structure, I think it's also allow us to start seeing how those operating systems being designed and why do they have some separation into layers. Okay, and then we talk about protection, that including memory protection, CPU protection, or whatnot. Okay, and then after that we spend almost quite more than half of the quarter talking about something related to process or processing, because process or processing is probably the most important aspect. When you use computer, you don't use computer, you use application that running on those computer. So the application that running is a process is an abstraction of your program in execution. Okay, and then within that process, I think we continue on talk about the how the process get managed, PCB, process control block, memory footprint of the process. We talk about inter-process communication. That means when you have more than one process, then the process may communicate to each other. Okay, and then we extend the concept of inter-process communication and talk about distributed system. Okay, which some of these ideas also touch upon or related to your presentation. Some of you got presentation later on. Then after we talk about process, okay, we also jump into CPU scheduling or process scheduling, okay, and then coming back and contrast process with thread, because thread is a lightweight process which is very suitable for current hardware technologies, those multi-core GPU. You're gonna hear more about multi-thread or parallel computing aspect, because you have more than one computing unit that you can execute. If you run traditional software that executes sequentially, it's not going to take advantage at application level in terms of when you have multi-cores, okay? So in that case, you need to start divide the task and then execute in parallel within application. So in that case, you have concurrency or parallel kind of computing in an application. You know, in for multi-core type of environment, operating system that manage schedule multitask. In that case, you can take advantage of multi-core by spreading the work, the workload into those core by CPU scheduling or process scheduling. After we talk about this thread, this process, then we also touch upon a concept of synchronization. When you have more than one processes or multi-thread to communicate, then you have to ensure the way how to control those communication, you know, send and receive. And we look into mutex, we look into mutual exclusion, okay, which is a way to regulate or control to make sure that we enable the communication in more predictable way. Because if we have two or more processes try to communicate, and then we don't enforce mutual exclusion or synchronization, the result may be unpredictable, okay? But however, if you lock and then trying to ensure synchronization and has forgotten to unlock, that may lead to the deadlock, meaning that your application will just hang forever or, you know, wait indefinitely, okay? And then after we discuss deadlock concept, by the way, we also have you study about p-thread and write dining philosopher application, so that you understand multi-threading concept as well as mutual exclusion, okay? Then we go on and into the next aspect of feature that quite crucial in operating system, which is memory management. Memory management will enable the system so that you can load application and running as a process. So without memory management, you would not have an ability to run any program as well as load the data into memory, okay? And then last but not least, or the main aspect of operating system, then we deep dive into file structure and file management to see how the data is permanently stored in your storage, okay? And then after that, you know, we start your presentation. So I think these three aspects, process, memory, and file, would be a major pillars or foundation of this operating system, which there are other features such as security, privacy, and all others, okay? But those are important peripheral kind of features that make your system more useful, okay? So, I mean, from your presentation, here are we have around 30 something each kind of presentation, but I'm trying to combine and then group them into categories, okay? And then you can see this color coded, okay? And by the way, I would upload this summary into our Moodle site too, okay? So I think one of the topic which we have I think 3 or 4 presentation is centered around AI, okay? I think two person talk about AI in operating system, and then one person talk about AI on compiler, okay? Which I'm seeing that AI would come into this not only in operating system, but also in most application in the future, period, okay? I think we can't avoid AI. So therefore, I would encourage everyone, if you still have some chance to take more classes, AI would be a good class for you to pick up, okay? Because I think definitely you should know how AIs work, um, and in fact, if you can go further, meaning that if you know how to program machine learning, I think that even gonna build up your resume and make it more attractive, okay? And then I think we have two person talk about booting process, okay, which is one of the critical initial state, how your operating system get load up into the hardware and start being ready for user to work on. Okay, so in that case, it gives you a good perspective how the boost master record and how when you turn on the firmware start checking and then continue on point to the node location so that you can start your OS image. Okay, and then after that you see all the green font, okay, which is including virtualization, Hyper-V, cloud computing, Docker, and Kubernetes, okay, which virtualization is just a foundation to technology or concept that you can create virtual storage, virtual machine, or whatnot, okay, and Hyper-V is a specific hypervisor or whatever virtual machine monitor you can view as an operating system of virtual machine. Okay, so with that, it would allow you to start seeing, not only your hardware that you can run operating system on the top. You can manage in a way that you will have a multiple copy of those virtual hardware so that you can run different operating system, and then extend from that concept. I mean, then you get into cloud computing, and beyond cloud computing, people talk about container or Docker, and last but not least, Kubernetes is even go further than whatever Docker concept or container concept. So these are also very important technologies, beyond operating system that you should put on your radar, because I suspect that at least half of you guys, or when you start getting into industry or working, I think you're gonna have to work on infrastructure in cloud computing or the environment that Docker environment or Kubernetes. Okay, moving on, then we have two areas that touch upon user interface, voice-based OS as well as Microsoft HoloLens. Okay, those are related to a somewhat user interface. Okay, which is also important aspect. And then the next set of presentation, it touch upon various operating systems, started from Embed OS, OS for IoT, iOS and Android, Firefox OS, which is now defunct, but then I think it segued to, I forgot the name, another new operating system that start with K. Someone present that, in the previous class. And then one guy talk about Arches Linux, SE Linux, React OS, and then Game OS. Okay. Last but not least, we also have two presentations that touch upon the hardware, which you should understand this hardware. GPU start play significant roles in real world computing, GPU. So I think this area or this hardware, you should at least maybe dabbing in and then start understand. Quantum computing, which is the last but not least presentation, is also bring a fresh perspective of how, computer technology get kind of improve, what technology that on horizon that we should kind of put on our focus or on our radar. Okay, so I think all and all this would conclude our class, and I believe that I don't know, because I I really like to have face-to-face in class meeting, so then I can have some feel, I can have body language and see how you react in presentation or in the class. This is the challenge time. We do the best we can try to make sure that we can enable you to learn something, you know. So I hope you guys have learned something, and this is the last chance before, you know, I mean, we get into summer. So anyone has any question or comment or suggestion, please feel free to provide. In fact, you know, I mean, don't be afraid that you're gonna make me feel bad, because next year is my last year. I always want to improve myself, so that, you know, I mean, this is my first time doing a full class online teaching for the whole quarter. I have done quite a bit in terms of video conferencing, but this is never done before. This is my first time do the online. I hope at least you learn something, you know. Uh, from what I have observed from your presentation, in fact, I'm very proud of you guys. You know, I can see the way you grow, the way you present, the way you react. Okay, so any question, any suggestion, any comments before I call, you know, the completion of this class, and wish you to have a great summer.
I just want to say, sir, it's really appreciate the things that you've been doing for this class and adapting to the online deal. It's been pretty tough for all of us, but I think you've done a great job with the transition, and I'm hoping that your last year is a little not going to be as you know, eventful as this spring quarter has been.
Mm-hmm. Okay, thanks, Carrick. I think it's nice of you give me a compliment, but you can say any negativity also, you know, not just you, everyone, because I mean, for me, the whole of my career, I always take both positive and negative. You know, the positive, I would take positive to be continue doing so, and negative, I want to improve myself, and I would encourage you, every one of you, also be open mind, because, you know, for me, I've been working for the past 30 years, you know, I mean, both academic and industry, and that's what I mean, I enjoy, and trying to not compete with other people, but compete with myself and keep learning every day, you know. So hopefully next year is my last academic year before I opt my early retirement. But, you know, I mean, feel free to stop by and pick my brain. In fact, some of my previous students, I mean, some of them being successful in industry, sometimes they come back and we communicate. And some of them come back and try to recruit, you know, you guys, you know. So I think next quarter or in the fall, I'm teaching 403. If we still have face-to-face meeting, I probably would try to invite those, you know, I mean, my previous student who has graduated and become successful, and then give a talk in the class, and some of them may come and try to, you know, offer some job opportunity as well, you know. But regardless, you know, feel free to stop by and pick my brain, talk about something, you know, or even letter of reference, you know, when you apply for the job, I have written multiple letter of reference, you know, I mean, for your potential employers too. Anyone else beside Carrick, you know, Kylie, you know, provide some nice compliment? Are you all awake? All right. So well,
I think everyone might just be
barely
shy.
awake.
go ahead. Hello?
Everyone might just be shy.
Yeah, that's fine. That's fine. All right. Okay. So keep in touch. And if you guys need to talk to me, even though, you know, I mean, I'm off, I don't have a duty during summer. This summer, I cancel all my trip. In fact, I have canceled 5 of my 6 trip this so far. As some of you guys may know, on my free time, I'm a I'm a photography centric tour leader, that I'm taking people around the world, photograph, you know, the wildlife. Okay, so This is the first summer that I stay put at home because of the COVID. So I cancel all my whatever the air travel. If you guys would like to speak with me or you have anything, challenge, send me email. I mean, we can do the Zoom and we can speak, okay? Don't be shy. I'll be happy because, I think what we'll try to do, I think we are with you. I mean, we want you guys to do well. We want you guys to be successful. All right. So without that, I wish everyone have a great summer. Stay safe and take care, everyone, including your family too. All right. Okay. I'm gonna shut down and well, hopefully we'll see each other next year. Bye now.